longest subarray with maximum bitwise and is today's Leetcode daily problem. It is rated as medium, and this question gives us an array nums, and we have to find out the maximum possible bitwise and of this array nums. I believe this question is quite self-explanatory. So this question is quite easy to understand as long as you know AND operation, the crux of AND operation. So when you AND a larger number with a smaller number, the resulting number will always be less than the larger number. Why so? I'll show you in this notepad over here. Right. So, as you can see, we'll take two numbers, right? 7 and 5, right? So, 7 is represented as 4 plus 2 plus 1. 7 is represented in binary as this. 5 is represented as 1, 0, 1, right? So what you the thing that you can notice over here is when you AND these bitwise AND these numbers, the resultant will be 1, 0, 1. That is 5. This will always be the case when you are doing bitwise AND operation on a larger number with a smaller number. Why? Because the most significant bit is, that is the bit on the left side, will always exist or will always be present for a larger number, right? So as you can see, the bit over here is exists for a larger number but not for a smaller number. Why? Because as you go towards MSB, the value increases, like from 2 to 4, 8, 16, 32. The value is increasing. So when you bitwise and a larger number, say 16, with a smaller number, say 12, right? We'll do 12 over here. You will always receive a smaller number, since this bitwise AND operation is essentially removing this part, means making, sorry, not removing, but making this part 0, the LSB part 0. So the pattern that you can notice over here is, you have the only way you can get a continuous subarray by bitwise AND is when you bitwise AND on similar numbers, the same, not similar, same numbers, right? Like over here we are using bitwise and on the same number, that is 3, and the question here asks for continuous subarray of it. So you need to find the continuous subarray of the maximum number present in this array. So the solving is quite simple. The code is quite simple. It uses two pass solution. First one to find the maximum out of this bunch over here, or the array over here, and the second for loop to find out the maximum, the size of the maximum subarray of the maximum number. So what we are doing is, we have a result for the final result and a local count to store the local count. So just because in case if an array arrives which is, say, some like this with 1 2 3 something, wait a second, 2 2 3 3. In this case, the answer will be the count of these threes. Hence, you need a local count to keep track of what is the maximum subarray. So, what we are doing is, for every number, we are checking if the number is equal to the maximum value. If it is equal to the maximum value, we are only increasing the local count and comparing it with the result, such that if the local count has exceeded the result, then it will update the result accordingly. If the number that we encounter while going through the array nums is not equal to the maximum value, we are resetting the local count to 0, because now we have the maximum value, now we have the maximum, or not maximum, but the count of subarrays of the maximum value. So once we submit it, I'll show you that this solution works properly. As you can see, this solution is quite efficient and works properly.